Today we're going to be discussing what happens to the volume and the surface area of a prism if we change a measurement by a certain amount. So when you change a measurement, that measurement is called an attribute. And basically all that is, it's the measurement for the length, the width, the height, or the radius of a prism, cylinder, pyramid, or cone. So we're going to be changing length, width, height, or sometimes the radius. So today we're going to focus on first what happens when you change one measurement. So we'll be changing one measurement, either the length, the width, or the height. So let's start out with the word double. What double means is that you are going to be using a scale factor of 2. And so what you're going to be doing is, whatever measurement they give you, you're going to be multiplying that measurement by 2. And so then what happens to the total volume of the prism? Well, if you double one measurement, then you're going to double the volume. And what happens to the surface area? The surface area is going to increase or get larger. You can also triple an attribute or measurement. So that means your scale factor is 3. And you would multiply the measurement they tell you to by 3. And so if you triple one measurement, then what happens to the volume? Well, that means you're going to be tripling the total volume of the prism, which also means that the surface area is going to increase. Now, another word you might see is half. Your scale factor would be 1/2. Which means you would multiply the measurement they tell you to either by 1/2 or 0.5. And so what happens to the volume? Well, if you have a measurement, then that means you're going to cut the volume in half. So for example, it might go from a total of 100 cubic centimeters, and if you have one of the measurements, then that means it would go down to 50 cubic centimeters. And so if you're cutting a measurement in half, then of course also the surface area is going to decrease. And then another one you might see commonly is if you decrease a measurement by 1/3. So you're multiplying your measurement by 1/3, which means you'll cut your total volume by 1/3. Which means, once again, your surface area is going to decrease. So now we're going to read our example. It says a juice box has a volume of approximately 60 inches cubed with a height of 5 inches. The box is cut in half to a height of 2.5 inches. So they're changing one measurement. How does the new volume compare to the original volume? Well, remember, if you are cutting one measurement in half, then that means your total volume is going to be cut in half. So our answer is going to be A. Now we're going to take a look at what happens if you change all of the measurements. So you change in a prism the length, the width, and the height. So we're going to be changing all the measurements here. The words will still be the same. So if you're using a scale factor, of 2, then you're going to be doubling all the measurements, which means that you would, if for volume of a prism, if it's length times width times height, you would do 2 times the length, you would double the width, and then you would also double the height. So then what happens to the volume? Well, let's think about it. If you are multiplying 2 times 2 times 2, it's going to mean that your volume is going to be 8 times larger. Which means, once again, your surface area is going to increase. Well, if you triple all the measurements, that means you're increasing each measurement by a scale factor of 3, which means you would triple your length, you would triple your width, and you would triple your height. So if you tripled every single measurement, then 3 times 3 times 3 means that your volume is going to get 27 times larger. And once again, your surface area will definitely increase. You can also halve all of the measurements. So in other words, you're multiplying every measurement by 1 or 0.5 or 1/2. And when you multiply all those together, you are going to get 1/8 the original size. So in other words, you're going to be 1/8 times smaller. And your surface area will decrease. And then if you're cutting every measurement by a third, then what that means is that every measurement, like the length, the width, and the height, are all by a third. Then that means you're doing 1/3 times smaller times 1/3 times 1/3, which will give you 1/27th times smaller. So that gets pretty small there. And your surface area would decrease. Here's an example below. The edges of the larger cube are 3 times longer than the edges of the smaller cube. The volume of the smaller cube is 8 cubic centimeters. What's the volume of the larger cube? Well, there's a couple things that we need to remember. First, if it's a cube, then all of the measurements are the same. So in other words, the length, the width, and the height are all the same number. I know that the smaller cube has a total volume of 8 cubic centimeters. So I need to figure out what number is the same that gives me 8 cubic centimeters. I know that 2 times 2 times 2 equals 8. So now what I need to figure out is what's the volume of the larger cube. And what they've done is they said that the larger cube is 3 times longer on every edge. So in other words, I'm going to take my volume and I'm going to multiply it by 3. So I'm going to do 2 times 3, which gives me 6. I'm going to multiply my width, which gives me 6. And I'm going to triple my height, which is also going to give me 6. And remember, to find volume, you do length times width times height. So in other words, for my large cube, I'm doing 6 times 6 times 6, which should equal 216 centimeters cubed.